Let me just make sure that I am all set up and ready to go with everything, including sharing my slides. That's going to be important here. So actually, before I start presenting my slides, I would like to just echo what Jason has already said and thank you all for showing up today and joining us for this meetup. And of course, Jason, I want to connect later and find out which ridiculous story you have to share. I saw Eric leaned in with a chef T-shirt, so I suspect that those two are somehow related. And I can guess what the story is, but I'm afraid there were a couple that were ridiculous, so I'm not sure exactly which one. I'd also just like to thank you for trying this meetup online like this. I think that while the coronavirus pandemic has certainly changed the way all of us work, it has opened up some new opportunities. So while this is the Fox Valley DevOps meetup group, I know I see some friends of mine that are joining currently from Amsterdam. I see some folks from Philadelphia that have joined. So by having this meetup online, we are opening it up to many more people, which I think is really, really great. I also, Jason and I had a conversation leading up to this talking about the time of day that we should host this. And we obviously landed, for those of you that are in Fox Valley or in that area, like we landed around lunchtime. We figure everyone is working from home. Maybe the lunch hour is better than trying to hold this at a typical meetup time in the evening. So hopefully this works out really well for you. And as Jason mentioned, we would really love to hear your feedback on how this all went. So with that said, I am going to go ahead and swap over to my slides here. And I want to note two things. First, hopefully you can see my slides. So a thumbs up or something would be great. Oh, you can't see them yet, but they're coming. All right, Jason, you can see them. Awesome. And as Jason mentioned, it would be great if you ask questions in the chat. But I've recently discovered or rediscovered, I don't remember if I knew about this before or not, but there's a great cool tool within Google Slides itself where you can actually have live questions and answers throughout the presentation. So on every slide, right at the top of the slide itself here will be this sort of banner that says ask a question at that URL. So you can go to that URL at any time and ask a question. I will see those, and then as we go through, I can answer some of those questions for you. And maybe maybe that's all I'll say on that. So let's get right into it then. So thank you again for joining. I want to talk about using error budgets to prioritize work. And I'll introduce myself a little bit more in a second, but before we get to that, we have a problem. Our problem here is that incentives are not aligned. We look to our developers in our organizations and we say, hey, your job is to build and ship features as fast as you possibly can. The faster you ship features, the more money we're going to pay you. The more likely it is you're going to get a bonus or get promoted or what have you. But then at the same time, we turn to our operators and we tell the operators of our systems, your job is to keep the systems up and reliable. Never let them fail. We want 100% reliability out of the systems all the time. And this sets up a real sort of friction between these two groups. I myself have a history as a system administrator, so I identify with the folks on the right side of that screen there. I'm an operator. And I understand the best way to maintain stability is to put up my hand and tell the developers, nope, you can't have any new features. We're not taking your new changes. We're going to stop them all. I can keep the systems running very happily. We have to fix this. The idea of fixing this is exactly where DevOps was born, or the ideas, the principles around DevOps were born. So how do we get these two groups collaborating together? And as if this isn't bad enough news, the news gets a little bit worse. Dev and ops don't sort of hold an exclusive lock on these misaligned priorities. These misaligned priorities happen all over our organizations. In fact, there are misaligned priorities between the business and IT. In fact, if we were over on the business side, for many business people, it's difficult for the business to actually distinguish between development and operations. Like, it's just IT. Just make it all work, make the systems work, make them fast, make them reliable, ship the features. at the same time, from an IT perspective, when we talk about the business, I'm doing it myself, and you've probably done it before. We use air quotes like the business. Just who is the business? Just who is IT? So the business, they're the folks that do the businessy things, things like marketing and sales and uh, uh, finance, like who pays the expense reports. That's an important part of the business. And when they look at IT, they ask the same thing, like who is IT? Well, we're the ones that do the engineering things. We build, we develop, we deploy, we operate, we manage software and systems. So these are really important questions for you to understand. And actually, I just lied to you. This is not really an important question to understand. The real question that we should be asking is not who is the business, but why is the business? Why does the business exist? What is the goal of our business? Who are the customers of our business? And how does the work that we do apply to that business and help further the goals of our business and help keep our customers happy? And so, with these ideas in mind, this thing called DevOps was born. And like DevOps, first, I think it's always been about how do we better align and utilize technology to help serve the business. So how do we align those incentives? How do we align those objectives across the entire organization? And frankly, I think DevOps is a pretty terrible word. It's a fine banner for us to get behind. But when you hear that word or when I say that word, you probably think of development and operations, two different departments. And we really want to change our entire organization. You cannot change an entire organization by focusing on only two departments within that organization. So the real question becomes this: why is the business? And I want to talk about a particular business really quickly, an online retailer. So let's just step back for a minute. We're going to talk a little bit of theory here for a second, we're going to get a little bit high level, but I'm going to bring us back to this idea of SRE and error budgets. So let's just think about an online retailer. Why does an online retailer exist? Why is their business? Well, if you think about an online retailer, they have goods that they want to sell. They have customers that want to buy them. So what does it mean for that online retailer to be reliable? How do you know if the system is working? Is it enough to say, well, the homepage is working, so therefore my system is up and it's working? That's probably not enough. What are some of the other criteria that we have to think about? Well, we might have to think about, can a user come to our site and see what's available for purchase? Can they browse the inventory? Can they search the inventory? If they find an item that they want, are we selecting or suggesting alternate products that they might want to purchase instead of the product that they're currently looking at, or in addition to the product that they're currently looking at? The truth is, I don't know. I don't know your business. You're probably not even an online retailer, but these are the questions that you need to start asking about your applications. So for a minute, let's just stick with this online retailer and let's just walk through like, what does a typical customer want to do? So a customer might want to browse the catalog. Let's see what's available for purchase. They might want to select an item from that catalog. This is the thing that I came here to buy today. And then they're going to purchase that item. So if you think about this, this is a typical user journey. And in Google, we use, and within SRE, we use a term called critical user journey, or a CUJ, critical user journey. So when we think about the services that we're running, it's always important for us to go back to not which piece of hardware is this running on, what's the application stack that this service runs. We have to ask, what is it doing for our users? And what are the users trying to do with this system? What are the critical user journeys? So in this instance, the example that I'm going to use, we're going to have a critical user journey of a user, a customer, wants to buy something from this online retailer. So these are the steps that they must go through. They have to be able to browse the catalog, select an item, and purchase. What does that look like from a systems perspective? Again, I'm going to keep it pretty high level. I'm not going to show you a bunch of code or anything, but let's just think about how might this work on the back end. So we have the browser. We have the user sits in their browser. They want to browse the catalog. They're going to make a request off to the server. So they're going to request /catalog from the server. The server is going to send back a list of items. The user or the customer looks at that list of items, selects one. and maybe they want to add that to the cart. So there's an API call or a URL that they point to when they click that button, add to cart, that sends some information off to the server. We get back a status. Thanks, that item has been added to the cart. Now we're ready to purchase it. So as a customer, I go to /checkout. So I hit like, I want to check out. I see the payment page. I give all of my payment details. And this is interesting now. We at this online retailer don't handle those payments ourselves. We actually send that information off to a third-party payment processor. So this charge gets made, some status comes back, and now I know that I've made that purchase. So this is what a critical user journey might look like for this particular online retailer. You can see there's lots of back and forth transactions that are happening, lots of different systems involved, both our back-end servers and like server. Obviously, there's microservices that are involved with that. There's probably some data store that's involved, maybe some cache on the front end, some load balancer, all these things that we have to worry about, and also this third-party payment processor. Well, at this particular online retailer, they do something that maybe you do today within your own business. On the operations side, they have regular operational reviews. So maybe once every week or once every 2 weeks, the operations team gets together and asks questions like this. What pages came in? Or what alerts did we receive? Which ones were actionable? Do we see any patterns? How can we eliminate some of the pages that we received with some engineering work? Can we automate some things? Can we build some better health into the system and so forth? All this with an idea that what we want to do is reduce our maintenance costs. We want to give our engineers lots of good work that they can do that's actually providing value to the system. Well, at this particular online retailer, in this particular ops review, they found a bug. They noticed that the time that it took from a user to click pay, and then that information gets sent off to the third party, and then a status page comes back, that time was increasing. So this wasn't a big bug. It wasn't like that payment process was broken. I'd say this was a little bug. It was a little bug in that latency was slowly increasing, right? So the operations team identified this issue, and they knew that over time, if we left this alone, here's what's going to happen. That payment processing is going to inch up in time that it takes. The latency is going to keep going up and up and up. And then eventually our customers are going to stop buying because they're going to get frustrated. They're going to lose faith or trust in our system. If you click buy and it takes 90 seconds for a status page to come back, I mean, we've all been there before. You know how anxiety inducing that can be. So that means you don't want to go back to that online retailer. The operations team knew if they didn't fix this, there was going to be a problem. So how did they do that? How did they go about resolving that? Well, IT did the thing that IT usually does. We said, hey, this is a problem. We're going to step up and we're going to fix that problem. And they started working on that problem. They worked on that problem sort of on the side of the desk, if you will. So, they put some extra cycles that they had to work on that. Maybe they started working evenings. Maybe they even worked on a weekend to help resolve this issue. In the meantime, the business or product managers kept pushing new features. Hey, I want this new feature. I want this new feature. I want this new feature. IT's over here trying to fix this latency issue and trying to respond to all this pressure to get and ship new features. We're running into this pressure and this friction between the two groups. So what was the net result? Well, IT fixed the bug eventually, but they were showing signs of burnout, right? All of our engineers were working evenings and weekends. They were kind of salty when they came into the office because they hadn't had enough sleep, because the business doesn't care about the really important work that's happening. At the same time, product management, they were frustrated. Man, I wish IT would develop things faster for us. I wish we could get new features out. Every time we ask for a new feature, it's a delay, and then it's another delay, and then it goes out and there's a bug, and it comes back, and then there's product management just gets frustrated. So we run into this scenario all the time. Maybe you've lived this yourself. Either you've been on the product management side and super frustrated with the speed and the pace that your development teams are providing in terms of feature velocity. Maybe you've been on the IT side and you're frustrated that product management just doesn't seem to listen to the real problems that are out there and the real work that you're doing. Well, this is where site reliability engineering, or SRE, can come in. The idea behind SRE is really how do we make our systems reliable in a way that is sustainable to the entire system. And when I talk about systems in that instance, I'm talking about more than just the servers or the cloud instances or the containers. When I talk about a system, I'm talking about the system that includes us, the people. We are part of this system. So how do we build a reliable system, not only for us, but also for the technology? How do we build a sustainable system that can do that? And so SRE gives us some indicators on exactly what we can do. There's a construct within the SRE practices called the error budget. And I want to talk about that error budget now. So to talk about an error budget, we have to start with a couple of other definitional terms first. The first one I want to talk about, or the first thing that SRE points us to, is this thing called an SLI, or a service level indicator. A service level indicator is some quantifiable measure of the service that a customer is receiving. So it's some indicator that the service is good or it's bad. It's working or it's not working. Now, when we think about our service level indicators, one thing is true. An SLI is just a metric. But another thing is true. Not every metric is an SLI, or a service level indicator. It is important to think about these SLIs in terms of how our customers are experiencing service from our systems. So as an example, I wonder, or I can virtually guarantee that most of you are measuring the CPU utilization of your systems. So you have, I don't know, 6,000 VMs. You could probably look at a dashboard right now and tell me how utilized are the CPUs on those VMs. Now that CPU utilization is a metric, it's a number, but it is not an SLI. It's not a service level indicator. And we know this because how many of your customers care what is the current CPU utilization of your system? None of your customers care about that. What your customer cares about is, can I buy that thing that I put into the shopping cart, right? So we really have to think about these SLIs in terms of how does our customer experience this? But, a customer experience, that feels kind of squishy. Like, how do you actually measure the customer experience? Well, we might go back to our system diagram and think about some of the transactions. How does our customer experience our system? Our customer has a number of different interactions, right? When they browse the catalog, there's a request response where I ask, give me the catalog, here's a list of items. The same thing when you're adding an item to the cart or when you're checking out. Each one of these are sort of unique services that we could put some SLIs around, including this eventual thing where we're going to check out. So maybe we came up with, for this particular system, an SLI around latency. And we worked with our customers, we worked with our product owners or our product management team, and we understood more about this system. Our product owners or our product managers said, listen, the latency shouldn't be bad. The payment status page should load quickly. And we all agreed to that and said, yes, that sounds like a really good SLI. The problem with this SLI, as it's stated, is it's not quantifiable. Like, what does that even mean that the status page should load quickly? Yes, it is something that our customers experience, but it's not something that we can really measure. So as we start defining SLIs, we need to dig a little bit deeper. We need to ask some additional questions. For example, how do we define quickly? Like, what does quickly mean? And where does our timer start and stop when we're going to load up that status page? So let's answer these questions. So we might say, well, it's the proportion of HTTP post requests that go to API or /API/pay. So remember, when a user wants to make a payment, they make an HTTP request. Obviously, it's probably an HTTPS request, but S, no S, whatever. The code on my slides totally compiled, so it's fine. And they're secure. So we make this post off to API/pay. And then how long does it take for us to get that response back? So this is how we're going to define our SLI. We're going to say within some certain number of milliseconds, we want the entire response to come back. We also have to ask the question of where are we going to measure that? We may have hundreds or even thousands of application servers that these transactions are flowing through. Do we have to collect and summarize the data from all of those? Or maybe we could just do those measurements at the load balancer. The truth is, when you're setting your SLIs, you want to be as close physically to your customer as you can. So that way you get the best measurement or indicator of your customer's actual experience. So if you think about this, measuring on the individual hosts that sit behind the load balancer, that's fine, but there's a lot of extra work we'll have to do. If we summarize this at the load balancer, that's where all of the requests have to come through. Now, of course, there are some downsides to this. What happens to every request that your customer makes, either from their browser or their phone, that never makes it to the load balancer? You're not going to measure those. Or likewise, the responses that leave the load balancer go back to your customer, but the customer is disconnected from their network, or their network connection is just bad. You're not going to have any of that data. So we want to get the best SLI that we can for the minimal amount of engineering work. Sometimes we may decide that the best or the minimal SLI that we need actually involves client-side instrumentation, and we have to go and build that into the client. But for our simple example that we're going to use today, we're just going to stick at the load balancer. But now we have this question of it should load the entire response within X milliseconds. Well, what is X? What's the value of X? And that's where we get into this thing called an SLO, or a service level objective. So what is an SLO? An SLO, or a service level objective, is a target that you want to set for your service level indicators. So how do we know, or how can we measure how our customers are experiencing our application? That's our SLI. How good do we want it to be? That's our SLO. And the real question is, in how good do we want it to be? There's a thing that I like to remember. We are engineers. I'm an engineer. You're probably an engineer if you're here. And one thing is true about all engineers. We love to be lazy. I only want to do as much work as I have to get whatever credit I want or to accomplish whatever goal I'm after. And that's exactly how you should set and target your SLOs. The idea of setting a service level objective to, let's say it's an availability objective, we'll say, to 100% available. That's ridiculous. You're never going to reach 100% availability. You have to do something less than that. So we want something that is going to keep a typical customer happy if we barely meet this. So when we think about that time to checkout, from the time I click pay to the time I get back a response, we know that waiting a minute is definitely too long. Customers are going to be filled with anxiety. They're not going to want to purchase from us again. They're going to be upset. They're going to be unhappy. If we have an unhappy or a sad customer, that's an indication that we're missing our target SLO. At the same time, if we hit it, we should have happy customers. Now, one thing to remember, when you're first setting these SLOs, you might not have enough data to know what should you set this SLO at. So you're going to pick something, and then you're going to review that. You're going to look at the data and adjust it accordingly. So I'm going to just pick some random SLOs for our latency SLI. So maybe we say that when the customer clicks purchase, they should get all of that response back within half a second. And not only that, we don't want to look at individuals, one by one. Let's look back over 28 days. So we're going to have a goal of 99% of these requests should get the full result back within 500 milliseconds, so half a second. And I'm going to look at all of the transactions looking back 28 days. And it's important to look back over 28 days so that we can sort of flatten the curve. So we can look at what is the trend, right? If I have a single transaction that falls well outside of the bounds of this, that's maybe okay. If I have 1,000 transactions that fall outside of the bound of this, that's probably not okay. So we need to figure out, what does that target window actually look like? And further, we might actually want to set a couple of service level objectives for each one of our SLIs. So in this case, it's great. If 99% are returned within half a second, that's pretty good. But if all 99% of those take a full half second, I think we can do better than that. So maybe we set an additional service level objective that says 75% come back within 200 milliseconds. So most come back in 200 milliseconds, and then most, and then almost all can come back within half a second, and then we're good. So this is how we, within SRE, start to measure the reliability of our services. We start with our service level indicators, which are an indicator of how our customer is experiencing that application. And then we add in targets for those service level indicators. So a target for our latency or a target for availability. Now, all of this, the SLIs and the SLOs, are built in service of a thing called an error budget. So what is an error budget? An error budget is how we will define and describe what reliability actually is. And in fact, our error budget, frankly, is an acceptable level of unreliability. So if we said 99% of those transactions had to be returned within half a second, if we changed the wording around, we would say the same thing if we said 1% of our transactions can take more than half a second. So that 1% is what we would call our error budget, the 1% of transactions. Let's flip it around and say we have an availability target. So let's say for every transaction that happens against our homepage, everyone that tries to load our homepage, we want our homepage to be available 99.9% of the time. In saying that, we are also saying it is acceptable for our homepage to not be available for 0.1% of the time, or 0.1% of the requests to the homepage can fail. So we can set up an agreement within our organization around these service level objectives. And that agreement can help us prioritize work. Now, an error budget that's agreed to is only as good as the consequences that go along with that error budget. And let me describe what I mean there. So what happens when we miss that number? Instead of 99% of the requests being returned within half a second, we see that 99% of the requests are being returned within a full second. We've overspent or exhausted our error budget. What does that mean in terms of how we prioritize work? Well, the most dramatic way to think about this is an error budget tells you whether or not you can ship new features. So if you've exhausted or overspent your error budget, no new features. We freeze all feature releases and we redirect all of our engineering work on reliability of the system. What can we do to make the system more reliable? And in the case where our SLO is only about latency, what can we do to make the system faster? And it doesn't matter which engineers you have on your team, you redirect the energy and efforts of all of those engineers to that one particular goal. This is very similar to what you see practiced in continuous integration and continuous delivery, where we have continuous testing that's running. And we have this mantra that when the build goes red or when the build fails, that becomes our top priority. And so this is taking that and extending it into an operational realm. When we miss our error budget, enhancing the reliability of the system becomes everyone's top priority. Now, the truth of the matter is, though, that if you're just getting started with SLIs and SLOs, this error budget consequence, freezing all feature releases, like I said, it's pretty drastic. And in fact, your organization probably isn't ready for that. So there are other consequences that we might use instead of that. Let me just walk through a couple of them. So one, you might prioritize your postmortem items. Now, I know this has never happened for you. It's certainly never happened for me at my last N employees or employers, but at some time in my past, I was responsible for running systems. Systems went down, we got them back up, and then we held a postmortem. And we said, all right, let's figure out what are the things that we could do to change the system so we don't fail like that. We came up with a list, we put them on our to-do list, and then we went back to work. And then 3 months later, another incident, another outage. We fixed it, got the systems back online. Whew, that's better. Let's have a postmortem. What should we do to prevent this from happening again? Oh, it's those things that are on the list that we put there last time. Like I said, it's never happened to you. Certainly has happened to me, right? So why don't we use this idea when we've overspent our error budget, we should then prioritize the postmortem items. And don't get me wrong, you should always prioritize your postmortem items. But if you're having trouble doing so, you can use the error budget as a way to help prioritize them. Same thing with automating deployments. If what you find is your deployments are like hard, that when you ship code, like the deployment is flaky and that's where things break, when you've overspent your error budget, focus your engineering efforts on fixing up those pipelines. Now, I did put an asterisk there because sometimes your process is broken. And so if you automate a broken process, what you get is a faster, consistent, broken process. So maybe don't do that. This is a good time. Anytime you automate something, it's a good time to stop and reflect and make sure that what you're automating is the thing that you actually want. Another quick one thing I'll mention here. It's the second to last one there on the list. Require SRE consultation. I've seen this work at a number of different customers. When the development team that's responsible for a service, when this service is out of error budget, it's extended or spent all of its error budget, an SRE is required to show up to the daily stand-up. And what happens here is maybe the developers are talking about, these are the projects or the stories that I'm working on this week or today. The SRE might start asking questions. And in fact, we could tie it right back to our online retailer. So the SRE might turn up and say, hey, I see that you're making a request off to this third-party payment provider. What is your retry logic if that request fails? What is your back off logic if we see that if it looks like that third party is being overloaded? Start asking these operational questions. And then once you get back into your normal error budget, right? You have error budget to spend, things are going back to normal. The SRE doesn't have to show up for that stand up anymore. But I have seen is when that SRE leaves, those application developers continue to ask themselves those same questions. So it's a learning moment or a teaching moment, helping our developers learn about building more operable applications. Okay, but an error budget isn't all just for bad. It's not all just about consequences. What do we spend our error budget on? Just like your own personal budget or your family budget or your company's budget, you have money that's there and it's allocated to be spent. So how do you spend that additional time that you have or that engineering effort? Well, error budgets can accommodate a bunch of different things. If we go back to our very dramatic and drastic, if you're out of error budget, you don't ship any new features. The corollary to that is if you have error budget available, you can ship all the features you want. And so within SRE, we want reliable systems, but we don't want to sacrifice we don't want to sacrifice velocity for that reliability, because we know that a customer doesn't care about a system they can't access. But your customers over time are going to be unhappy with your applications or your services that never change also. So we want to balance these two things. We want the velocity to be as fast as possible when shipping out features. So if we have error budget available, we can release new features. We can have planned downtime. We know that we need to upgrade these systems. They have to come offline. Let's do that in a way that does not overextend our error budget. We can also run some risky experiments. I'll give you a great example of a risky experiment. I mentioned earlier that when you set your SLIs and your SLOs the first time, you don't really know, are these the right SLIs? Are these the right SLOs? Earlier I said that 99% of requests should be returned within 500 milliseconds. Well, is 500 milliseconds correct? Are your customers going to be just as happy with 500 milliseconds as they are with 600 milliseconds? What about 700 milliseconds? Where do we find that tipping point for our customer? Well, if we aren't sure, we could use some of our error budget capacity to run a risky experiment. Let's take 10% of those payment requests and inject 50 milliseconds of latency, 100 milliseconds of latency, and then compare the users that got the latency experiment versus the regular, full speed control group. Is there a change in behavior? If there's not a change in behavior, then maybe that's an indication that we can be a little bit slower. And that's okay. That tells us that we don't need to maybe invest as much. We could invest that energy and invest that money in our system elsewhere. So we can run some risky experiments with our error budget. But here's one of the most important parts. The error budget is an agreement that helps you prioritize engineering work. And it is really, really important that this agreement is reached across your team, across both dev and ops, throughout the organization, all the way through to the product teams, the executives, who's prioritizing the work of engineering. Those people need to be bought into this idea of an error budget. Because once you've spent an error budget, it is too late to decide on what the consequences are. You have to decide what are the consequences of overspending your error budget before you've overspent it. You have to decide on how are we going to spend this error budget before you've overspent it, before you have reliability issues. And probably the most critical thing to remember is that all of this, as you're getting started, you're going to set the wrong SLIs, target the wrong SLOs, and come up with bad error budget agreements. That's okay. You're going to iterate on them. You're going to learn from them. You're going to have to take a moment to reflect on them, adjust them, test them again. Right? This is an iterative process, and it must become an intentional practice within your organization. You have to set out with some goals in mind. You have to go and do some work, and then you have to revisit. Did that work actually help us move closer to our objective, move closer to our goals? Okay, with that, I want to share one link with you here. There are two SRE books that Google has published in conjunction with O'Reilly. You can read them both for free right here at this URL, landing.google.com/SRE/books. They're both available, like I said, online in an HTML format. Of course, you can buy a paperback version of these books from your favorite retailer as well. And with that, I don't see any questions that came in across the slides. So I am going to check the chat because I think maybe I saw a question come in there. All right, wondering about how to effectively add new automated coverage for metrics pertaining to new features as they were released. For example, working closely with app devs to understand where the instrumentation needs to go, somehow making it just happen. Yeah. Okay. So Ryan, this is a great question. I'm gonna say some words, and actually, Ryan, if you're still around, do you want to come off mute and maybe uh, restate your question, or just ask it again to make sure that I fully understand it? Oh, perfect. Well, good on me then. Awesome. Yeah, I think there's a couple of different things. Some of it depends on sort of the infrastructure, the deployment platform that you're running on. So let's say, for example, if you're running in Kubernetes or something and you have a service mesh, whether that's Istio or something along those lines, like it can make that metrics gathering very, very easy. And I also think that having services expose some sort of health endpoint that gives some information about the health of that service. And if you can agree across all of your services, like this is the common endpoint, it's at /health for every service or whatever that is. Here's maybe a specific structure that you use. Then you can start building up those monitors very, very easily, and they can just happen automatically. So does that help, Ryan? Awesome. Maxwell pointed out another book just released, not free though, is Building Secure and Reliable Systems. Yes, I think that book was just released today. It's another SRE book. published by Google in conjunction with O'Reilly. And while it's not free, I'm not making any guarantees, but I suspect that it will eventually land in that same place. And then Philip asked a question, do you need to have a good understanding of A/B testing you share with the business sponsor to do this at all? Um, So I think it is, I think what you need, frankly, is across IT and the business, we need to have an organization that embraces this idea of experimentation and learning. Now, does that mean they have to know sort of the particulars of A/B testing? Maybe, maybe not. But what they do need to understand is that none of us know enough about our systems to make the best decisions all the time. So there will be experimentation. And in a good experiment, like we can just go back to like sixth grade science and lean on the scientific method, right? We'll come up with some theory, we'll come up with some way to test that theory, we'll run that test, and then we'll look at the results. I think one of the sort of anti-patterns I see is a lot of organizations use the word like we're a learning organization or say we're into experiments, we're a data-driven organization. And the data that they use is what is sometimes referred to as the HIPPO. Do y'all know HIPPO? The HIPPO data? HIPPO is the highest paid person's opinion. HIPPO, the highest paid person's opinion. That's the data that we use to make all of our decisions. Like, that's no good. But many organizations who claim to be data driven do that. Claim to be like, we're a learning organization. I think we should try this. We're going to try this, and then I'm going to tell you how it worked. So it's important that we run experiments and that we're honest and almost dispassionately look at the data and the results of those experiments and decide, should we move forward with this? Should we roll it back? Should we go a different direction? Yeah. So Philip, I hope that answers your question. If you have a follow-up, take yourself off mute and ask. Yes. Right. Yes. And I do think that you're definitely hitting on something there. Like I think it's easy for the business to think about IT as a thing that you do and then it's done, and now that system works. But they recognize, like just like they do annual budget planning, they recognize that the plans once they start executing are going to change, and the same is true with our IT systems. And I think here's the important bit, Philip. I think it's you and the team have to become sort of closer to the business, just in the same way that we want them to be closer to IT. And I think the best way to do that, like the DevOpsy way to do that, in my very strong opinion, is to find someone from the business and go to lunch with them. I think all of the challenges that we run into, or not all, many of the challenges that we run into within our organizations, is there's a lot of what I will call othering, right? So if I'm dev and ops is supposed to run my thing, ops is the other, right? Why won't you run this stuff? Why does the stuff I build you keep breaking? It works fine on my laptop. And from an ops side, why do you keep giving me junk and asking me to run it? Like I don't care that it works on your laptop. It doesn't work at scale, right? But we're just othering one another. Like that's someone else's job, or legal and finance, like all of this. So I think we have to get to know one another and understand, like go to lunch with someone from the business. Go to lunch with your product owner. Get to know that person as a human first and allow them to get to know you as a human, and then start talking about, all right, well, what are the business things we're trying to accomplish? But I think that it's an easy step for us to overlook, but it is human nature for us to kind of want to cast someone out or blame someone else because they're the other, and we oftentimes do that before we actually get to know them. And you've probably experienced this yourself, whether it was you doing it or you being othered. When you got to know that other, your relationship changed, it improved, and it got much better. So I hope that helps. All right. Well, I want to thank you again for coming out for this presentation. I will make sure, Jason, that you get a copy of all the slides so that you can share them with everyone. And I'll stick around for additional questions. And I just, the beauty of this online format is that we can meet all together in the same virtual space at a time that is hopefully convenient for everyone. But the downside, of course, is that there's not a whole lot of networking. We can't really do a whole lot of discussions with one another. I find that the best part of meetups are the people that you meet. I don't know the best way to solve for that now. Maybe I'll ask this question. If you currently are hiring or looking for work, one or the other, either hiring or looking for work, maybe you're doing both, why don't you take yourself off mute, introduce yourself, and tell folks that that's what you're doing. All right. I know that silence feels really awkward. Jason, I'm going to turn it back over to you. I'm going to suggest that you give it at least 7 more seconds of awkward silence before you chime in case someone does want to mention anything.